Hello, welcome to yet another interesting episode of the program Aqua Farming. And Aqua Farming is a program that brings to you all you need to know that is in the water. Call it crabs, shrimps, fish, and what have you. As far as it concerns the water, this is what we do on this very program on your first ever agricultural television station in the nation, talking about Agricultural Research Council of Nigerian Television. And today we'll be looking at land-based aquaculture systems. Growing fish in land-based aquaculture systems in close and controlled environment reduces the risk of disease contamination. No antibiotics or diseases treatments are involved in a normal production process, so the fish produced are completely natural and healthier. Take a look at how it works.
Now, today on Aqua Farming, we're going to be looking at land-based aquaculture. The answer to fish farming. Eating fish often feels like we are making a better choice. Typically, fish has less saturated fat than meat and a wider range of beneficial compounds like omega-3 oils, said to reduce cardiovascular disease. In a restaurant, we may console ourselves that the higher price tag means we are talking into the dish freshly caught and prepared locally. The more sustainability-minded among us might also consider the fish favorable carbon footprint compared to a similar portion of beef, pork, or chicken. On the face of it, fish is indeed superior to meat from a sustainability perspective. In the wild, herbivorous fish consume algae and are in turn eaten by their carnivorous counterparts. The process requires no deforestation or for grazing, nor otherwise productive land is given to produce feedstock, and no chemical interventions are required in order to grow or maintain supply. However, harvesting fish at an industrial scale has clearly environmental consequences. These range from overfishing to ecosystem destruction and costs. Plastic pollution from fishing equipment, according to Greenpeace so-called ghost gear, accounts for 100% of all plastic ocean pollution. Now, let's look at how fish farming addresses the shortcomings of industrial fisheries. Fish farming or aquaculture presents solutions to some of these problems. The most commonly farmed fish are catfish and tilapia, both grown in freshwater inland. Salmon, the most valuable aquaculture species, are farmed in coastal marine waters. As with wild fish, no forest has been lost, and while grain is fed to farm fish, the conversion of those grains into protein is more than 5% more efficient than beef. The superior feed conversion ratio means for fewer resources are used in the production of fish, beef. Consequently, the advantages are economic as well as environmental. The consumption of fish has accordingly skyrocketed. Partly, this is due to the surging global population, with the world expected to reach 9 billion inhabitants by the year 2050. However, according to the United Nations Food and Agriculture Organization, the global consumption of fish has increased at twice the rate of population growth. Since 1961 at 3.3%, absolute demand for protein has thus been reinforced by raising average incomes with perceptions of health and status, meaning that fish consumption has outpaced the growth of all other animal proteins. Aquaculture has stepped in to meet the demand, as FAO chart below shows. Now, let's look at the major challenges that salmon farming faces. Farming salmon fishes create three main problems. Chief among these are parasitic sea lice. These crustaceans are transferred from wild fish into the healthy salmon, feeding on their skin and blood. As with lice in human population, high-density fish farms make for rampant infestation and, in extreme case, mass mortality. In trying to solve these, however, farms have created a new setback. Treating sea lice requires the use of harsh chemicals. Over time, the lice have evolved to build up a resistance, necessitating the use of harsher treatment. These chemicals are then combined with antibiotics to treat the diseases impacting the health of both the farmed salmon and, as they wash out to sea, the surrounding ecology. The relationship between density and surrounding is also at the heat of issue. Number 3, influent like cows, sheep, or any farm animal. Salmon generate excrement. Without proper disposal, the organic matter can build up to levels which destabilize local ecosystem, a process known as eutrophication. A nutrient-rich effluent collect algae, build up, decompose, a defined seawater, and ultimately lower oxygen content. The result is an acidic low-oxygen environment, unsuitable for marine life. Land-based salmon farming offers a potential solution. Adult salmon are cold water, marine fish typically found in Scottish Lodge or New Wigan. As such, salmon farms have historically needed to be in locations as similar as possible to the fish's natural habitat without the associated fallout. Once caught, the fish must be frozen and transported, often by air or as a prevent spoilage, to their eventual destination for consumption. An innovative technology known as recirculating aquaculture system means this is no longer the case, allowing salmon to be kept in large indoor tank with every element monitored and controlled. This ranges from temperature to lightning, waste products, and even artificial currents. From an environmental perspective, the closed-loop system means effluents can be removed, treated, and disposed of safely while also eliminating any exposure to sea-borne parasites or disease. Lastly, the water itself is purified and reused. While the technology often isn't new, it is only the combination of the rising prices and industry pressure which has conspired to make it commercially viable. Now, let's look at keys enablers for sustainable land-based salmon farming solution. We look for companies that are providing long-term sustainable solution to the planet, ever-growing demand for nutrition. A Nigerian company has indoor farm in two of the world's largest salmon market sites in Lagos and Kano. Not only address the industry environmental challenges directly, but also bring product closer to the point of consumption. This means products are fresher, while transportation costs and associated emissions are lower. These environmental benefits go hand in hand with financial advantages. The closed loop naturally lowers the incidence of parasites and disease, in turn reducing fish wastage and the need for costly chemical treatment. At the same time, retaining effluent with RAS creates a smaller environmental footprint, minimizing the likelihood of costly remediation at the hands of regulators. Indeed, far from a potential cost, effluent can become a new revenue stream properly treated. Fish excrement can be used as a fertilizer, producing income and further improving agricultural contribution to the environment. In land-based aquaculture, nitrogen waste products and organic carbon waste are produced during the fish growth cycle. It includes compartments for the anaerobic digestion of organic solid collected from the fish tanks, coupled to sulfate reduction. Heterotrophic and autotrophic denitrification using organic compounds and sulfate is electron donors for nitrate reduction, as well as the anamox process. Coupling anamox and denitrification process in the same reactor resulted in the simultaneous uptake of sulfide, ammonia, and nitrate under anaerobic conditions, created a process termed demonox. Moreover, the organic sludge generated by the system was consumed partially as an endogenous carbon source for denitrification. A remaining sludge was converted to biogas, metagenic bioreactor. The combined processes ultimately reduced the total volume of discharged organic solid by more than 96, and resulted in the production of methane may be harvested and used directly as an energy source. Since salt-laden sludge generated by it cannot be used for fertilizer as landfill system components, it has been proven that land-based fish farm using flow-through system without any water treatment may lead to negative impact in streams. Fish farming activities can generate considerable amount of suspended solid nutrients and organic matter from fish feces, metabolic excretion products, and uneaten feed. Fish farm effluents can cause an increase in concentration of organic matter nutrient and suspend solid and a drop in dissolved oxygen level in receiving stream water. Fish farming activities can generate considerable amount of suspended solid nutrients and organic matter from fish feces, metabolic excretion product, and uneaten feed, cause increase in concentration of organic matter. However, no significant differences between the UV and CTR groups were found. It can be explained by the very low board concentration in our system as compared to typical levels in the intensive through land-based aquaculture system. Such low levels might have limited the detection of an improvement in the UV treatment. Aquaponics combine two growing technologies: hydroponics, growing of plants without soil, and aquaculture, growing of fish or other aquatic organisms. It also called a balanced ecosystem. Climate change, which affects most natural ecosystems, can have more effect on large semi-controlled aquaculture systems by lowering water quality, leading to increased stress and disease outbreak.
The land-based aquaculture system has been in existence in one form or another since the mid-1950s. However, only in the past few years has their potential grow fish on a commercial scale been realized when water quality technology testing and monitoring instrumentation and computer-enhanced system design programs, much of it developed for the waste water treatment industry, have been incorporated and have revolutionized our ability to grow fish in tank culture. Nevertheless, despite its apparent potential, land-based aquaculture should be considered a high-risk experimental form of agriculture at this time. They can be used to culture high densities of fish annually, but their ability to do so economically remains to be demonstrated conclusively and repeatedly. Let's look at the benefits of land-based aquaculture. Land-based aquaculture offers fish producers a variety of important advantages over open and pond culture. These include a method to maximize production in a limited supply of water and land, nearly complete environment to maximize fish growth year-round, the flexibility to locate production facilities near large markets, complete and convenient harvesting, and quick and effective disease control. Land-based aquaculture can be of various size, ranging from large-scale production system over £1 million per year to intermediate-sized system of £500 per year to small system of £50 per year. They can be used as grow-out system to produce food fish or hatcheries to produce eggs and fingerling sport fish for stocking and ornamental fish for home aquariums. Land-based aquaculture applies to the broiler, house, or swine bind concept to prevalent and effective use in modern poultry and pork production system. To realize number of fish in a relatively small space, indoor fish farming in tanks may revolutionize fish production in the same way that confinement system altered the pork and poultry farming industries. This is an excellent alternative to open culture where low densities, intensive culture of fish are rare, free in large ponds, and are subject to losses from disease, parasites, predation, pollutants, stress, and seasonally suboptimal growing conditions. Now, let's look at water and land conserved of Land-based aquaculture. Land-based aquaculture conserves both water and land. They maximize production relative to small area of land and use a relatively small volume of water. For example, using a land-based aquaculture is possible to produce over 100,000 pounds of fish in a 5,000 square building, whereas 20 acres of outdoor pond will be necessary to produce an equal amount of fish with traditional open culture. Similarly, since water is reused, the water volume requirement in land-based aquaculture are only about 20% of what conventional open and culture demands. They offer a promising solution to water use conflicts, water quality, and waste disposal. These concerns will continue to intensify in the future as water demand for a variety of uses escalates. Land-based aquaculture are particularly useful in areas where land and water is expensive and not readily available. They require relatively small amounts of land and water. They are the most suitable in northern areas where a cool climate can slow fish growth in outdoor systems and prevent year-round production. Land-based aquaculture provides growers who are geographically disadvantaged because of a relatively short growing season, less than 20 days, or extremely dry desert condition, a competitive, profitable year-round fish production system. They can be located close to a large market, urban areas, and thereby reduce hauling distance and transportation cost. Land-based aquaculture can use municipal water supplies and discharge waste into sanitary sewage systems. Nearly all species of food, fish and sport fish that commonly reared in ponds, including catfish, trout, and street bass, can readily be grown in high density when confined in tank systems. Land-based aquaculture are currently used to grow catfish, striped bass, tilapia, crawfish, blue crabs, oysters, mussels, aquarium pets. Indoor fish culture systems offer considerable flexibility, grow a wide diversity of fish species, rear a number of different species simultaneously in the same tank. Land-based aquaculture afford growers the opportunity to manipulate production to meet demand throughout the year and to harvest at the most profitable times during the year. This flexibility in the selection of species and harvest time allow the grower to rapidly respond to a changing marketplace in order to maximize production and profitability. Land-based aquaculture permits the grower to competitively respond to market price and demand fluctuations by altering harvest rates and time and the species culture. Tank culture systems are now being used to hold and purge contaminated off flavor and board rare cash until they are acceptable for marketing. Land-based aquaculture do have some disadvantage when compared to open pond culture. They are relatively expensive system to develop, building tanks and plumbing biofilters, and to operate. Moreover, they are complex system and require skilled technical assistance to manage successfully. Constant supervision and skilled technical support are required to manage and maintain a relatively complex circulation, aeration, and biofilter system, and to conduct water quality analysis. The danger of mechanical or electrical power failure and resulting fish loss is always a major concern when rearing fish in high densities and small water volumes. Operating at or near maximum carrying capacity requires fails, safeties, in the form of emergency alarms and backup power and pump system. The business and biological risk factors are corresponding high continuous vigilance, related complete circulation, aeration, and biofilters. Operating or near maximum carrying capacity requires fail-safes in form of emergency alarms and backup power and pump system. The business and biological risk factors are corresponding high continuous vigilance and quick reaction times are needed to avert a total mortality. However, the higher risk factor capacity, capital investment, and operation costs can be offset by continuous production, reduced stress, improved growth, and production of superior production in the RAS. Now, let's look at the land-based design. The functional part of a land-based aquaculture includes growing tank, sump of particulate removal device, biofilters, oxygen injection, U-tube aeration, and water circulation pump, depending on the water temperature and fish species selected. A water heating system may be necessary. Ozone and ultraviolet sterilization also may be advantage to reduce organic and bacterial loads. Water supply. A good supply of water, adequate in both quality and quantity, is essential to successful fish farming enterprise.
Land-based aquaculture, or otherwise, groundwater obtained from deep wells of spring is the best source of water for fish culture. It generally is free of pollutants and has relatively high hardness level, which are beneficial under some circumstances. Municipal water supply also can be used after chlorine, fluoride, and other chemical are removed. Other sources of water, particularly surface water from streams, rivers, ponds, and lakes, are not recommended for fish culture. Surface waters may contain fish disease, parasites, pesticides, and other pollutants that can kill or slow the growth of fish. Testing the quality of the availability water supply is one of the first steps of a prospective fish farmer to take and ensure adequate supply of high quality water. Because land-based aquaculture recycle most of their water, they consume considerably less than other types of culture and are especially well adapted to areas with limited water supplies. The required quantity of water needed to grow fish varies, with the species of fish selected, size of culture system, and investment size. As a general rule, a minimum water volume of 1 to 5 gallons is needed to every pound of fish reared and minimum water flows. Tank culture systems are referred to as circulating system because they recycle reuse water. No system is over completely closed because some water must be added periodically to replace evaporated losses and that used to flush out waste material. Some water change and necessary system, no filter is 100% effective. Nevertheless, land-based aquaculture can operate efficiently by occasionally adding only a relatively small amount of water on a daily or weekly basis. Open system refers to those that simply allow water a single pass through the system before it discards. Flow-through system can also be used in indoor tank culture of fish if an abundant and continuous supply of high-quality water is available. Trout farmers typically use open systems rather than recirculating ones because trout require large volumes of high-quality cold water. Open systems leak most of the water quickly, whereas closed systems leak water slowly. Land-based aquaculture are more suitable for warmer fish such as channel catfish, trickberries, and tilapia that can tolerate lower water quality conditions and higher temperature than trout. They also are now being used to rear marine species such as redfish, oysters, clams, and offshore blue crabs. Fish can be grown in tank of nearly every shape and size. Fish tanks typically are rectangular, circular, or oval in shape. Circular or oval tank with central drains are somewhat easier to clean and circulate water through than rectangular ones. Rectangular tanks are usually built with or set upon inclined floors or facilitate cleaning and circulation. Rearing tanks range in size from 500 to 5,000 gallons capacity. The size of the tank depends on a variety of factors including stocking rates, species selected, water supply, water quality, and economic consideration. The tank must be designed to correspond with the capacity of all the components of the systems, particularly size of the biofilter and sump, so that all parts of the system are synchronized. Tank can be constructed of plastic, concrete, metal, wood, glass, rubber, and plastic sheeting or any other materials that will hold water, not corrode, and not toxic to fish. Smooth surfaces on the inside of the tanks are recommended to prevent skin abrasions and infections to the fish and to permit cleaning and sterilization. Lightweight durable plastic tank can be conveniently moved and readily cleaned when necessary, but they require special support to prevent stretching when filled with water. Stainless steel to also a good tank material but can be expensive. Marine grade plywood tank are expensive but leak if not properly sealed and are not as a durable tank for them. Other materials. Concrete tanks may be the most economical to build, but they are relatively permanent and immovable structures once constructed. Non-toxic plastic or rubber linens can be used for frames made of wood, metal, concrete, or other materials.
Welcome back on that. Now, as wild fishery diminish and demand for seafood continues to grow in Nigeria, land-based aquaculture is a promising production method with wide-ranging applicability. On that note, we come to the end of the program. See you same time, same station. Bye for now.